says the following are graphs of molecular velocities on the x-axis versus the relative number of molecules on the y-axis for neon, argon, krypton, and xenon at 300 Kelvin. Which graph is for krypton? If I go down my periodic table here, it's neon, argon, krypton, and xenon. So xenon is the heaviest, and neon is the lightest for the molar mass. Well, each atom and each mole. Now, we're going to see today two kinds of graphs a bit like this. We're going to see ones with velocity on the x-axis, and we're going to see ones with kinetic energy. So this is one with velocity, and if you are doing the homework, you can see it's kind of blurry, but it says velocity and it actually gives some numbers. And what's important is at the same temperature, T, capital T is temperature, so heavier gases move more slowly. And now we need to interpret this statement in terms of the graphs that we're seeing. And what I would suggest is that the next thing we need to know about these graphs is that all of these graphs have the same area under the curve. And by area under the curve, what I mean is, so if I were to color this in, and I were to color, well, this one sort of runs off the screen, but if I was to color this one in, even if they don't look like it, these two areas would be exactly the same. This would be the same area. And if I continued this out a little farther until it actually came back to the x-axis, this area would be the same too. So the only difference between these graphs is the distribution of velocities. So, and you can think about that because on the x or on the y-axis, it says, so this graph says relative number of molecules. In the graphs from the lecture outline, it said fraction of molecules. And for each of these plots, the fraction of molecules adds up to the total of 1, just like the fractions of a pi. I see the question there. I'll answer that one in a minute. So the fractions of a pi always add up to 1 pi. Same thing here. Anyway, and then the last main point about these graphs is that whenever you have a gas, some of the gas particles are moving slowly with a low velocity. Some of them are moving faster. The gas particles are not all moving at the same speed. The gas particles are moving at different speeds. The gas particles are moving at different speeds. That's important when you think about how reactions happen. So some of the faster ones will tend to react, while some of the slower ones won't have enough energy to react. Anyway, we'll think about that in the future. So one of these days I'm going to actually answer this question. And the question says, which graph is for krypton? Krypton is not the heaviest. It is the second heaviest. And so what we need to do is we need to look at each of these curves and see which one, let's say this, the heaviest one is going to be closest to 0. And I would suggest this one is closest to 0. And I did my best actually to make the graphs line up when you do the homework, but I certainly didn't make them line up here. It turns out that the one that's closest to 0 is also the tallest because it's squinching that same area, so closer to 0. So closest to 0 one, also tallest. This one is the next closest to 0, so it's the next heaviest. Oh, so also tallest, heaviest. This is next closest to 0. So it is next heaviest. And since the next heaviest one is krypton, this one is krypton. So we would circle C here. And what you'll see when you do these is that I ask you for sometimes krypton and sometimes the other ones as well. Okay. And we do a bunch of these questions.